Alright, so this example is a practice in Newton's third law. There are 3 blocks at rest on the floor with weights labeled. The force on the lowermost block, from the force of the lowermost block on the middle block is going to be what? Okay, pause the video, draw a free body diagram for each of these, and try to solve for the force of basically the 5 Newton block that's being applied to the 10 Newton block. Alright, so I'll go ahead and draw the free body diagram for each of the blocks, and I'm going to label them. I'm going to call them 1, 2, and 3. So the free body diagram for the third block, we have force of gravity 3 acting down, and we have force from block 2 on 3 acting upward. Then the free body diagram for this block is basically force of gravity on the weight of 2 acting down. Then we have force of block 1 on 2 acting upward. But then we also have block 3 on top that's pushing down. So we basically have F3 on 2 pushing us downward. And then finally, for the last block, we have its force of gravity of 1 pushing down. We have the normal force from the table pushing up. I'm just going to call it normal, but essentially it's F table on 1. Then we have the 10 Newton block right above it that's pushing down, so basically downward F2 on 1. Now, just to point it out real quick, let's identify our Newton's third law pairs. F2 on 1 is a Newton's third law pair with F1 on 2. They are in opposite directions, but they are equal in magnitude. Then F3 on 2 is a Newton's third law pair with F2 on 3. All right, now it's just a matter of doing some algebra. So we know some of the forces on each of these blocks in the y direction is 0 because the system's at rest. So let's start with some of the forces in the y direction on block 3, which is F23 minus Fg3, which is equal to 0. So that basically tells us F23 is equal to force of gravity on block 3, which is equal to 20 newtons. So what we've just identified is this here ends up being 20 newtons as a result. Well, if this is 20 newtons, you know the magnitude of F3 on 2, which is a pair, is also going to end up being 20 newtons. So when we do the sum of the forces on block number 2 in the y direction, we get F12 minus F32 minus F gravity 2 all equals 0. So that tells us that F12 is equal to Fg2 plus F32. Well, force of gravity of block 2 is 10 newtons. 10 newtons plus, we just found that F23 is 20, and we know F23 is the same magnitude as F32, so that's also 20 newtons. That tells us is F12 is equal to 30 newtons. Now we could go ahead and do the sum of the forces on the last block, which we will in a minute, but we've already answered the question. What's the force that the lowest most block applies on the middle block? Well, block 1 on 2. That's F1 on 2, which we found to be 30 newtons. Now to check our work as a sanity check, let's go ahead and do the sum on this last block. So sum of the forces on block, 1. Sum of the forces on block 1 in the y direction is equal to normal force minus F21 minus Fg1 is equal to 0. Alright, so that tells us that the normal force should be Fg1 plus F21. And Fg1 is 5 newtons plus F21 we just found to be 30 newtons, which is a total of 35 newtons. This is nice because let's go ahead and consider this whole system of 3 blocks as one big block. If this is one big block, then the free body diagram for that big block is just Fg from block 1, 2, 3, so sum them up, and then the normal force, which is going to be the same normal force as is in this case. Well, Fg 1, 2, 3 is the sum of all the weights. What's 20 plus 10 plus 5 is 35. Well, that tells us if this is 35 and this is in equilibrium, the normal force would also be 35 newtons. That's great because when we solve for the normal force by treating them individually, we also got 35 newtons. So you can do this last part as a sanity check, just to make sure that you've done the sum of the forces on the 3 individual blocks correctly.